Hi, I'm Manuel Vivo. I'm an Android engineer in the developer relations team at Google. This video is about an introduction to coroutines. We will talk about the problems the coroutines are trying to solve, how to use coroutines in Android, how to test them, etc. The first thing we want to talk about is what problems are they actually trying to solve. They basically simplify asynchronous programming on Android. So whenever we talk about asynchronous programming, we cannot forget about synchronous programming. Here we have the function loadData, which is going to display on the screen the result of a network request. And because this is synchronous, it means that it will block the thread where this is being running on. So imagine if we call loadData from the main UI thread, network request will block the thread whenever it is waiting for the network request to happen. And so in this case, if the operating system is trying to call onDraw, that is not going to happen. And therefore, the user will see a frozen UI and unresponsive application. It will get unblocked whenever the network request finishes, and it calls show, as we can see. Let's see the definition of network request here. Network request is just a function that returns data, and inside it we have the blocking network request code. Blocking the main UI thread is something that we shouldn't do in Android. So how can we move this network request to a different thread? How can we make it asynchronous? A solution for this is using callbacks. We have the same version of loadData, which is going to make the network request on a different thread. Here, as we can see, if we execute this code, we can see that network request will be called, and we will see later that the function network request is going to be moving the execution of the network request to a different thread. And in this case, the main UI thread is free, and the operating system can call onDraw and refresh the screen as much as it wants. Whenever the network request finishes, it will call this lambda, a callback, that is going to display the result of the network request on the screen. If we take a look at network request, now it's just a function that doesn't return data anymore. It returns unit. And instead, it takes in a callback, a lambda that we call in this case onSuccess, with what to do after the network request finishes. We can call defaultscheduler.execute to move the execution of the network request to a different thread. And after that finishes, then we can post to the main thread calling onSuccess. So while callbacks might be an okay solution for some use cases, it has some problems. First thing is that now this is a simple function that it just makes another request and displays something on the screen. But now the logic can get complicated. We can start adding a nesting network request after the other one happens, and then we can add more stuff. And this is what becomes the callback hell. Whenever there is a lot of indentation, error propagation might be difficult. You have hard-coded posting to main thread whenever something happens, and you might not want to do that. It's complicated. What if we could have the best of both worlds? The simplicity of synchronous code with all the power from asynchronicity and moving things between threads. And this is where coroutines come in. Here we have the same function, loadData, written with coroutines. It might look a little bit suspicious. You might think it will block the main UI thread, but it won't. The only difference that we have is this suspend modifier in the function definition. That's basically telling the Kotlin compiler that this function needs to be executed within a coroutine. So how does it work? How can network request not block the UI thread whenever it moves to a different thread? Well, coroutines can suspend execution without blocking the thread, and that's gonna happen whenever we move to execute something to a different thread. So that's what we call the suspension point. But also, whenever that network request finishes, then we will resume execution. So whenever the network request is done with whatever it has to do, loadData can resume execution and continuing with the result of that network request. If you take a closer look, you will see that apart from network request, the rest of the function is that what we used to have before as a callback. So what is happening with the callback? The Kotlin compiler will write that callback for you under the hood, when the computation can suspend. And actually, coroutines call those callbacks a continuation. Continuation is just a generic callback interface with extra information in it. So how is the compiler going to modify the function load data? Well, it will take the suspend modifier and replace it by a parameter of type continuation. And continuation forms this state machine in which it will be executed depending if the function is suspended or not. So we can see that when it starts, the function starts, it will start with a state 0. Whenever it suspends, it will change state. Whenever it resumes, it will be back to a different state, and then it will finish. This is what is called continuation passing style. And because it's quite a complicated topic, it is not going to be covered in this presentation. But as you can see, it's just a fancy way to say callbacks. So with coroutines, computations can get suspended without blocking the thread, as we said before. Back to our function load data, we're going to see what network request looks like in this case. We will see that network request is another suspend function, but now it returns data as the synchronous version of it. How can network request move the execution to a different thread? Well, it uses withContext. WithContext is a suspend function from the coroutines library that takes in a dispatcher as a parameter. Dispatcher is basically a way to say, hey, I want to run this computation in this particular thread, and in this case, in I/O. And inside withContext, we can have our blocking network request code. It doesn't matter if it's blocking the I/O thread. What is important is that it's not blocking the main UI thread. What other dispatchers do we have available? We have dispatchers.io, but also .default and dispatchers.main. I/O is optimized to do network and disk operations. You use default for CPU-intensive tasks, and main for UI code or non-blocking code that executes quite fast. So here, network requests, we can say that this is main safe. You can call network request from the main UI thread, and it will be okay, because it will be in charge to move the execution to a different thread. So now we saw what problems coroutines are trying to solve, which is simplifying asynchronous programming in Android. But what is a coroutine? You can think of a coroutine as a runnable with superpowers. If you think about it, it is going to take a block of code and it will be able to run it in a particular thread. What I like about coroutines is that asynchronicity can be expressed in a sequential way, and that's going to be easier to read and understand. It also comes with other perks, such as exception handling and cancellation, that is typically more difficult to do with other versions, for example, callbacks. Back to our function load data, imagine that we want to execute that whenever the user taps on a button. For example, we can have this function on button clicked that will trigger load data. But this is not going to compile, because suspend functions must be called inside a coroutine. We don't know how to create coroutines yet. We will see that later. But in a nutshell, you can see we can use launch to trigger a coroutine. So imagine that this works. Here, some problems may arise. For example, who can cancel the execution of that coroutine? Does it follow a particular life cycle? For example, if the user is moving away from the screen, can you automatically cancel it? Who is going to get the exception if that fails? These are the questions that structured concurrency is trying to solve. So structured concurrency is a design pattern system in coroutines that tries to solve memory leaks. And structured concurrency forces you to think about those questions whenever you are working with coroutines. And it does it by introducing this new concept, which is a scope, a coroutine scope. Coroutine scope is going to keep track of the coroutines it creates. It's going to give you the ability to cancel them, and it's going to be notified whenever a failure happens. So now, back to our function on button clicked, that will actually give another compiler error. That's because launch must be called within a scope. How can we create a coroutine scope? A scope is just a simple variable that is really cheap to create. It is not going to hold references to heavy objects. So whenever you want to control the lifecycle of a coroutine, you can create a coroutine scope. So in this case, we can use this scope to trigger the computation. And that computation will follow, that coroutine will follow the lifecycle of that particular scope. So in this case, if load data throws an exception, the scope will get that exception and will handle it in some way. coroutines also create this hierarchy in which the root of the hierarchy is going to be the scope, which is going to be the parents of the other coroutines that it creates. So in this case, for example, whenever we don't need the scope anymore, for example, if we are in a view model, whenever we call onClear, we can call scope.cancel. And canceling a scope means that it will cancel all the children coroutines that it started, and it means as well that you cannot start more coroutines with that scope. So with our function load data, we can see that this suspend function, because it's suspend, means that it has to be run inside a coroutine. It will run in a scope. And this is quite important. If we take a step back and we think about synchronous code again, we can see that when a function returns, it means that it has completed all work. So imagine about the synchronous version of load data. Even it blocked the thread, it's okay, but it returned whenever it completed everything it had to do. With coroutines, it's kind of the same. When a suspend function returns, means that it has completed all work. And this is a very nice contract to have in asynchronous operations. So now we're going to see how to handle exceptions. Scopes can also take a job, and a job is going to define the life cycle of either the scope and also the coroutines. And whenever we passing a job to a scope, that means that it's going to handle exceptions in a particular way. When a child fails, it is going to propagate the cancellation to other children. And when a failure is notified, the scope is going to cancel himself and propagate the exception up. That means that in this case, whenever load data fails, it will notify the scope that it failed. The scope will cancel the other children that it may have created before. It will cancel itself and will propagate the exception up. In this case, because we are in a view model and there is nothing else in the hierarchy, it will make your application crash. But this might not be desired in every situation. For example, here we are in a UI-related scope, and therefore we might not want that behavior. So you can use the alternative, which is supervisor job. And with a supervisor job, if the failure of a child, it is not going to affect other children. And so with the failure, when a failure is notified, the scope is not going to do anything. So in this case, load data, if it throws an exception, the scope will say, okay, I have this exception, but it's not going to cancel other children. But FYI, the exception can be propagated still. So you might have to try catch it. TLDR for structured concurrency. When a suspend function returns, it means that it has completed all work. When the scope is cancelled, it means that the children will be cancelled too. When the coroutine errors out, the scope will get notified, and depending on the job, it will behave in a way or another. We're going to see how to create coroutines now. Before, we saw that we can use launch to do that, but it is not the only way you can do it. You have launch and async as well. We're going to compare them with the similarities and differences between these two different approaches. As I said, the first similarity is that they can create a new coroutine. They can start a computation where you can call suspend functions. But they create coroutines with a different purpose. So launch is going to create a coroutine that is meant to be fired and forgotten. So imagine that we have our login service where we can upload logs that happened in our application. So we can use scope.launch to trigger that computation, and that's it. We don't care about it anymore. That's launch. Async is going to create a new coroutine that can return a value. So for example, we have this function getUser that takes in a user ID as a parameter, and it returns a user object. Because we are in a suspend function, we don't have a scope available, so if we want to create a coroutine, we can use coroutine scope. And inside here, we can fetch our user with our user service, and that computation can be happening in dispatchers.io, for example, as we have there. And that is async is gonna return a deferred object. And you can think of a deferred object as a future or a promise in Java. And with that future or that deferred object, you can call await. And await will suspend the execution of the coroutine until async has finished doing its computation, and it will return the value of that coroutine. And this is what we return back to getUser. Another similarity, as you saw, is that both of them take a dispatcher. Where do you want to run that computation? Also, both of them are executed in a scope. Launch and async are extension functions on scope, on coroutine scope in this case. And so, in order to create one, you need a scope. They are not a suspend functions, so launch and async are the entry point to coroutines, how you can create a coroutine so that you can call suspend functions, but they are not suspend functions. And they differ on the way they handle exceptions. So launch is going to throw the exception as soon as it happens, and async is going to hold on that exception until you call await. We're going to see more of that in a second. So how you can handle those exceptions? Basically with a try catch. Here in our version of launch we had before, because login service can throw an exception, you can wrap it inside a try catch, and that will handle the exception thrown by the login service. With async, it's a bit different. As we said, async is not going to throw the exception. Therefore, you don't need to wrap it inside the try catch. You have to do it with await. Await can throw the exception that happened in the async block of code. Therefore, you have to wrap it inside try catch. And there you will handle that exception. Now we are going to move on to a different topic. We have this coroutine on the screen that is called with launch, and it's going to happen in an IO thread. So we have a for loop which is going to read files from a list. What happens if we call scope.cancel? Is that going to cancel the execution of that coroutine or not? Well, in fact, it is not going to do that because cancellation requires cooperation. Whenever you are doing something very expensive, in this case, we can spend a lot of time reading the files, you have to cooperate and make this cancelable. If you think about it, the coroutine or the thread is going to be really busy reading files, and it is not going to be listening for cancellation. So in this case, you have to cooperate and check if the coroutine is active or not. And you can do that by checking, for example, or calling ensure active or yield. Whenever the coroutine is cancelled and that function is called, then it will stop the execution of this coroutine. So again, if you are doing a heavy computation, make sure that you check for cancellation. We created a lot of functions throughout the presentation. And some of them were marked with suspend, some others weren't. When do you actually have to mark something as suspend? Well, this is easy. It's whenever it calls other suspend functions. So imagine our load data function, as we had before, it is a suspend function. Why is that a suspend function? Because it calls network request. That is also a suspend function. Why is network request a suspend function? Well, because it called with context, and with context is a suspend function that comes from the coroutines library. This is the reason why. But now, when don't you have to mark it as a suspend? Well, whenever it doesn't call other suspend functions. So on button clicked, is just a function that triggers the coroutine. It calls launch. And because launch is not a suspend function, on button click doesn't need to be either. So the tip is, don't mark a function suspend unless you are forced to. And in this case, you either mark it as a suspend or you start the coroutine, as we did with on button clicked. We're going to see how to test coroutines now. So testing asynchronous code is quite difficult because you want a deterministic behavior. You want the test to behave always in the same way. And we're going to see different use cases for the different ways that you have to do that. The first use case is for those tests that don't trigger the execution of a new coroutine. So for example, let's say we want to test load data. Load data, it is not calling async or launch. It is a suspend function. It's not triggering new coroutines. Even though it is moving to a different thread with context, that is what network request is doing, it is not creating a new coroutine. So we are okay here. This is the first use case. You can test this using run blocking. Run blocking is a method from the coroutines library that is going to start a coroutine and it's going to block the thread where it's being called until everything finishes, until the block of code finishes. So in this case, we can create a view model instance called load data, and load data is going to be executed synchronously. And so we can make sure that the next line after load data means that load data has finished doing everything. So now we can assert that show did something. That was quite easy, right? The second use case is more complicated, and it's for tests that trigger new coroutines. So for example, we have my view model, and we want to test on button clicked. On button clicked is triggering a new computation, is triggering a new coroutine calling launch. Can we use the same way as we did before run blocking? Well, if we think about it, whenever you call on button clicked, it is gonna run a new coroutine, and that coroutine might be potentially running on a different thread. And so it is gonna happen asynchronously. So on button clicked, it's gonna call launch, and it's gonna move on, it's gonna end the function. So whenever you call assert, it might be happening that the other coroutine is still running. Therefore, it's not reliable, you cannot use it. Another way is waiting for something to happen. So imagine that you update some result somehow, and you wait for that to have a new value, either having a Kotlin latch, or using live data test util if you're using live data, or with Mockito await. You have different ways to wait for something to be there. But that's a code smell. That's because the test is not gonna be running fast. It might take a couple of seconds for something to be there, and that's kind of a bad practice. The thing is that you might have to run it sequentially, as we did before with run blocking. And how can you do that? Well, basically, we can do that by forcing the coroutine to run in a particular dispatcher. And the good practice for this is injecting dispatchers. So in this case, for the view model, you can inject a dispatcher in the constructor, and then use that dispatcher to trigger the coroutine inside on button clicked. And now in our tests, we can use a test coroutine dispatcher. We create this test coroutine dispatcher instance that we are going to pass into the view model. So that coroutine is going to be executed in this test coroutine dispatcher. And in the test, instead of using run blocking to grab our test body within it, we're going to use the function run blocking test from the test dispatcher. That means that every coroutine running on that dispatcher is going to be executed synchronously. In that case, whenever we call on button clicked, it is going to execute that coroutine synchronously. That means that whenever on button clicked finishes, it means that the coroutine has finished too. And now you can assert whenever show did something without having to wait for that to happen. But now imagine that on button clicked has to do something else before running the coroutine. How can we test that? Well, test coroutine dispatcher comes with nice functions to be able to pause the execution of coroutines and to resume them. So in this case, we can call testDispatcher.poseDispatcher to assert that something happened before the coroutine, and then call testDispatcher.resumeDispatcher to test what happened after the coroutine run. So for testing, use run blocking when the test doesn't create new coroutines, and as a good practice, inject dispatchers and use test coroutine dispatcher in tests whenever you want to test something that is going to trigger new coroutines. That's going to be the end of the video. We went through a lot of stuff. So we said what problems coroutines are trying to solve in Android, which is simplifying asynchronous programming, how we can move the execution to a different thread using dispatchers and with context, what a coroutine is, that basically you can think of it as a runnable with superpowers, how coroutines work under the hood. The Kotlin compiler will rewrite that suspend functions to use callbacks, the principles of structured concurrency that is going to avoid memory leaks and is going to force you to think of who is going to manage the life cycle of that coroutine whenever you are working with them, how to create coroutines and the differences between launch and async, how to handle exceptions, when to mark a function as a suspend or not, and testing coroutines and the usage of test coroutine dispatcher. If you are interested in more things about coroutines, I suggest that you go through the different code labs that we have available. We have two of them, a basic code lab and advanced code lab that uses live data, coroutine builder, and more advanced topics. If you are more interested in testing coroutines, there is a video at Android Developer Summit 2019 where I give a talk with Sean. And then for cancellation and exceptions, another video in Kotlin Conf 2019 with Florina Muntenescu. Thank you for watching. Bye.